Lab 10. Components of vectors and its relation to trigonometry. Vectors are quantities that have both magnitude and directions to describe things like velocities, forces, and accelerations, or later on electric field, a magnetic field, or direction of torrents. And then those quantities that has both direction and a magnitude. To represent a vector, okay, it's a mathematical entity. On paper, we can have two different approaches. One is to use a graphic representation, which is the arrow like this, and the direction, of course, is the direction of the arrow, and the magnitude is simply proportional to the length of this. And also another way is to by components, okay, which means if it's in two dimensions, the vector is just represented by two numbers. As you see in the picture, this boy run across road, but in this direction, okay, and this distance is 24 feet. And so we represent the displacement, which is a vector, by this arrow here. So the direction is this direction, and the magnitude is 24 feet. So that's simple graphic representation. Now, if we want to get by components, we can imagine the road has decomposed into two directions. So along the road is our x direction, and across road in our y direction. So then you would do a projection on x direction. So if you do this, and if you do this, you will see you do a dashed line here, this way, okay, about this long. So then so that's our x components. So now I would guess, okay, I will ask you to guess many of these guess questions. So if this is 24, this is sort of like, I would say 18 or 19. Okay, 19 feet. So its x components is 19 feet. And then the y components, or the crossroad components, is going this way. Basically, the components has its real meaning is like along the road, it actually went 18 feet instead of 24. And across the road is not 24 either. It is maybe, I think, maybe 17. Okay, you may disagree with me on this, but that's just quantitative difference. But qualitatively, you have to agree that's both of them are much shorter than the 24 feet. But I would say these are the components. What I would call it a projection onto the x direction. How do you get its components? If you get x components, you do a projection, which you draw a perpendicular line to the x-axis, and then you measure this distance. That's its x components. And then you measure this distance, and this y components. So once you get these components, how do you write this into a component representation? You put these two numbers, 18, all right, and common 17. All right, so that's okay. You can either use this arrow or you can use these two components representations. Normally, we will denote a vector or represent a vector with a letter, but to differentiate with other quantities, scalar. By the way, I said it. I used the word scalar. And so far, any other quantities you're dealing with are scalar, which means simply a number. If this quantity has a direction and has magnitude, and so it's not a scalar, so they will be you note by this letter and the arrow or hat on top of it. That's one of the notation. It's like in the algebra, you say a, b, x, y, z, and usually those are scalars. But then if you basically simply have a number, your GPA, temperature, pressure or the amount of blood pressure, and all these are scalars, numbers. You just denote those with a letter. But here, if it's a vector, you denote them, just put on hat. This is the way to denote a vector, right? So of course, or sometimes you denote like this, x components, y components. In our particular example, and this one is actually, for this boy crossing the road, so there's 18, so when dx is 18 and dy is 17. So that's all means the same. So this one, if you don't know, you say, well, that vector, so this is actually displacement vector. All right, so let's just give a name. So that's kind of displacement vector, denote that. And so that's in general. Mathematically, we obtain a vector by projecting onto x and y axis. So I'm repeating it myself already. All right, in this lab, we just have a very simple thing to do. Okay, number one, find the components of vectors. The following vectors are in a graphic representation. Okay, they are drawn to the actual size in centimeter. In fact, with right-hand rule coordinates, find out the vector components representations. The following figure are printed out and handed out to you in paper. So you will receive a handout, but if you miss the lab, you go ahead and print out this on paper, okay? And then I will hand you rulers to actually measure in the components units. To measure in centimeters. Okay, for example, let me do this first one. So say you receive first handout. You do the components. So you say, first of all, you sort of know how big it is, and you will do so measured in the components. So then this, if you print out the paper, centimeter about this long, so this is like 3.3 centimeters. So its magnitude is 3.3. Okay, and then you project this in x components and y components. So the x components this way, y components this way. So if that's 3.3, if you use a ruler, okay, I'm just illustrating how you're supposed to do it. You're supposed to do it precisely with a ruler. So this is 1, 2, okay, 2.9. So this is 2.9. Okay, approximately, and that one is shorter. So this is 1. So this side is 1.5. All right, so 1.5. Therefore, you write this, and you write this being 2.9. The first is x components, okay, and then there will be y components. Okay, you can easily generate this to 3D, which means in a 3D vector. So I use this for a lab because this concept is very important, although very simple, but you have to know the concept. If we study 3D physics and then we represent vector in components, that's how you get from the component representation to the graphic representation, the component representation to the graphic representation. And this one, I will let you do it with a ruler, okay, handed out, and this one has positive. And this one I give indication. So if I have x direction positive, okay, so x positive direction, so x, and that's y positive direction. This one you have a negative y components and a negative x direction. So, but you get it. And this one you will get a and this one you will get a positive and negative. So negative. So some we will have different directions. So this one we will have a positive y direction and negative x direction. But you just put in the numbers. I already did the first one for you. No, I take that back. The first one is just a guess. You try. You should do better. And when you print out on the paper. Well, to represent a vector on the paper, you can also use two numbers, but this time you don't really decompose them into components, and that's important. You just put a parenthesis, write down the magnitude, basically how long it is, how strong it is, and the angle. is direction. So you all have learned the trigonometries, angles, and so then you will determine the directions. Okay, you have magnitude and direction. What is magnitude? It's measured with a ruler. And what's the angle? So this one is basically a review. You're supposed to determine the directions. By giving, so for example, first one, I would say that is 47 degree. You write the 47 degree there, and that whatever degree, just right there. And so, just to give you an idea, guess what this is? How many degrees is this one? Okay, and so this is the review. So that's the coordinate system. That's why. And this angle is about 60 degree. Right. So I'm guessing. Okay. And how about this angle? So this angle is about from here to here is about 120. So, and then how about this angle? Okay, that angle is go all the way from here 180 and a little more, so maybe 200 degree. Okay, and so on. 200. And what about this? So the 270. Okay, maybe 300 degree. Okay, and for the whole circle and all around, and that is, you're right, 360 degrees. So then you just put on the degrees and put in there. By the way, to hand in, you have to put a very nicely Word document. Okay, don't send me to that. You need to submit the nicely written lab report. Okay, and then once you do that, and then you have the degrees, and to all the vectors in here, you have the degrees, and at the same time you measure the magnitude and angle, put in this format. So which means at least you know the notation on the paper or in a book. Okay, so 3.1 47, so which means the first one I measured 3.1, but of course it's stretched longer than 3.1. But in fact, you should use exactly the paper and use a ruler to measure how long it is and then put in here. And this one, for example, this is maybe 1.9, and so how many degrees? Maybe 19 degree. So the second one will be maybe 2.9, 1.9, 19 degree, so and so on. So all these you just write down that. And this one is actually an easy lab, and very, very important. If we're in the lab, we will come from here to convert between this representation to this component representation. So this is component representation, and this one is the magnitude and the direction representation, which means you have a magnitude and an angle. All right. So enjoy your lab. So, if you have any question, make an appointment, or we can chat over Zoom, or you can make an appointment, come in office hours or any other time. Let's arrange it. All right. Thank you. Bye.